In this video, we'll be talking about what is C++, the language. So the first thing to note is that it's a general purpose language. It's a language that's meant to solve many different problems as opposed to a specific one. In that way, it's a lot like Python. They're both meant to solve general problems. It's also imperative. What does that mean? C++ is all about telling the computer, do this, then do this, then do this. And if you tell the computer to do the right things in the right order, it will do, hopefully, what you want. It's also object-oriented, meaning that the way that you solve problems with C++ involves creating objects, using methods and data within those objects. It's very much focused on the creation of these structures. We'll be talking a lot about how to use objects in C++ very shortly. C++ was developed by Bjorn Solstrup. I probably butchering that name. Luckily, all you need to know for exams is, to be able to look it up in your notes. Quite a while ago, before likely almost all of you were born, and it's called C++ because it's actually the language C, which some of you may have heard of, which is actually a kind of a simpler language than C++, and they added on additional features to it, most notably objects. So what some people call C++ was C with objects, but over time it's become much, much more than that. There's been some large changes to the language over the years. A big notable one was in 1989 when C++ 2.0 was released. And then the language stayed mostly static until 2011 when C++ 11 was released that added a whole lot of changes, actually mostly to the standard template library, but to the language itself as well. The version of the language we're going to be using in this class is an extension on C++ 11. So an important thing to justify is, why are we bothering teaching you C++? Many of you already know a programming language, likely Python. Why do you need to learn another language? Well, the important thing to note is that there's a lot of different types of programming languages, and some programming languages are much better suited for some tasks than others. Python is often a very useful programming language, but there are a lot of downsides to it. For instance, Python is generally relatively slow compared to languages like C++. What some people do is they divide the language into two types. They talk about scripty type languages, which are useful for kind of general tasks when you don't really care as much about performance as just getting it done. And so for that, Python works really well. There's also the time when you actually want a language that's very fast, very efficient, the ability to do more complicated tasks, the ability where you need a lot more control and finesse than a kind of a brute force language like Python would give you. And so for that, you turn to things like C++, C, Rust. There's some other Go. There's some other languages that care a whole lot more about performance, but they have to sacrifice sometimes ease of programming to make that happen. So, because many of you learned Python, it's important to talk about how C++ is different from Python. One of the biggest differences is that in C++, you compile your code. What does that mean? It means you write your code just like you would in Python, you save it to a text file, and then you ask another program to actually take that C++ source file, process it into a file that your computer can run, and often that process will reveal errors and things like that. And then the machine code, the binary file that compiler creates, you actually run that program later. So you actually separate the kind of taking your C++ program and turning it into a form that the computer can run, and then later then you run the program. Whereas in Python, those two steps happen simultaneously. And when you're doing both the compiling and running at the same time, this is often called interpretation. So Python is an interpreted language, whereas in C++ you can separate those two stages. In order to get a lot of the power that C++ provides, it means that we have to actually do a fair bit more work often when we're writing our code, meaning we have to be really explicit about, for instance, when is the program allowed to access new memory? When is that program done with that memory? In Python, the interpreter actually handles pretty much all of this without the programmer having to think about it. You don't have to say where this object needs to be stored or in what form or when you're done with it. Python, the interpreter, handles that for you. In C++, you generally have to manage it yourself. And so because of that, C++ is often a lot buggier. It's often a lot more challenging to write good C++ programs. But when you do, they're often much faster and much better than an equivalent program in Python. So because C++ has this compiler, you actually have two different types of errors you have to worry about. In Python, these were kind of merged into just Python is upset with your code. In C++, you have this distinction between compile time errors, which are errors that the compiler can determine. Usually these result for when you break the rules of C++. For instance, if you forget to include a semicolon, or you have an open parenthesis without a closed parenthesis, or you're doing something weird with types. We'll talk a lot more about these later. These are things when the compiler goes, you've given me code that doesn't make sense to me. The compiler will flag the error, give up, and it won't create an executable. It won't create this binary file that your computer can run because the compiler didn't know what to do with your code. Most of the errors you're going to create in this class are likely compile time errors because as you're learning C++, the compiler is going to be the thing that's enforcing that you're writing valid C++. On the other side, say your code compiles and makes it, you were able to generate an executable, but when you run the executable, it does something wrong. So for instance, I can write a program that says 1 plus 2 is 7. Okay, and just prints out 1 plus 2 is 7. Now, that code is perfectly valid C++. It'll compile. You can run the code, but the output from the code is wrong. Okay, that's a runtime error. It means that when your program was running, then it revealed its bug. So, it's valid C++, but it's not doing what you want the program to do. So this is a runtime error. All right, next we're going to talk a little bit about the most important library in C++, the standard template library. There's a bunch of other libraries, third-party libraries that you can either write yourself or download from the internet. The standard template library provides a whole lot of good and useful code. However, the parts of the library that we're going to be focusing on in this class are containers, the code that can hold data, algorithms, which are libraries and functions and things like that that often work on containers to generate output that we desire, as well as memory management. C++, one of the big powerful things about C++ is you have a lot of control over how memory is used by your program, but it also means we have to teach you how to control memory with your program. So, once again, more differences that we can talk about between Python and C++ at this point. One important thing to do is to talk about types. So in Python, you learned about a bunch of different types. What are types? Things like ints, or lists, or dictionaries, or strings. All the data in Python has a particular type. But in Python, it has what's called dynamic typing, meaning that just by looking at the source code, you can't be sure what the type of X is. But when you're running the code, you can always just ask X, hey X, what is your type? Python also has what's called duck typing, where it doesn't actually care what the type of X is exactly. It just cares that, for instance, X is printable when you're trying to print X. It doesn't need to know a lot of those details. It'll just kind of figure it out as the program is running. Whereas in C++, it has what's called static typing, meaning when the code is being compiled, it needs to know the type of every single variable in your program. There are a whole lot of types in C++. As many types are in Python plus more. You can create your own custom types as well. There's a lot of modifiers to types. So for instance, you might have an int, but you can also have a pointer to an int. We're going to be talking a lot about pointers later on in this class. You can have references to int. You can have ints that are constant. So even though you have a lot of types, you have a lot of ways to modify and make those types more specific. And the other thing, which will be really annoying for a lot of you, but also very important in ensuring you have correct code, is that the compiler must know the type of everything. Every single line of your code is going to need to know the types of all the variables involved in your code before it will compile it. So often, in making sure that your code compiles, you're actually making sure your code is correctly typed. And in C++, you have to declare all of those types. You can't just let the compiler try to figure it out. You have to say X is an int or Y is a string. So for example, here is a crazy line, which it should look crazy to you guys right now, but by the end of this class, it should be a pretty easy line to understand. Here is one line of C++ code. The green part here is all part of a type declaration. It's saying, here is the type of M. Okay, do you see the M there after the green bit? And this is a constant pointer to a constant map of strings to a vector of longs. Once again, this is meant mostly to scare you at this point, but it's to let you know that the type of M is sometimes a mouthful. All right. Now, the other thing that's important to note here is that you have to tell the compiler what the type of M is before you're allowed to use it, before you're allowed to assign it some value, which is what's happening on the right side of the equal sign. And so in order to do this, it means that whenever you're writing code, it requires context. It means that what code means depends on what's around it. And unfortunately, because C++ was built on top of the C language, we talked about that a bit earlier, it means that sometimes the syntax for C++ isn't the prettiest. And so often symbols get reused to mean different things, depending on what the context around them. Once again, there's only so many different types of parentheses, different types of commas and things like that. So often they get reused. So for example, if you have AA space BB open parentheses CC close parentheses semicolon, depending on what AA, BB, and CC have been previously declared as, this could be that we're trying to declare an object named BB that has type AA, and we're using the constructor and passing it a single argument CC. Okay? Or this could be the declaration of a function named BB that takes an object of type CC and its return type is AA. Just from looking at this line, we can't actually tell which of the two things it are unless we have a bit more context for things around it. Alright, so here are some more modifiers to types. Once again, we're going to be spending a lot of time later on in the course to talk about what the difference between references and pointers and things like that are. In the first line, we're declaring a long, which is a type of integer named myInt. Okay, everybody with me on that? In the next line, you see the little ampersand before the name? It's saying that we're declaring a long reference named refint. The little star or asterisk on the third line is what denotes a pointer, and this is a long pointer. And on the fourth line, the asterisk there does not actually denote a pointer. The asterisk there is denoting a dereference operation. And on the last line, the asterisk there actually means something completely different, and that just means multiplication, like 5 times 7. So once again, what these symbols mean change based on their context. Alright, another thing that I have to warn you about is C++, when you type C++ badly and you run the compiler will often give you huge amounts of error messages, and it can be overwhelming. Don't stress out about it. Simple mistakes can often generate huge amounts of error output. The thing you really want to focus on is at the very end, you want to look at like what line is at the very end of the error message. So for instance, here is some code output that I've gotten, and what you need to do is you want to look at the very end. So you look down here and it says, okay, in the file named sizes.cpp on line 9, character 39 of that line, it's having some issue with something about deriving. Don't need to worry too much about the details. And it's saying, hey, it doesn't like this last line here. See out, the exact syntax here, I haven't taught you guys yet. The reason for this error is I should have had 2 less than symbols here instead of just 1. It generates a whole bunch of garbage up above, but the important thing is there's something wrong with this line. I should look more carefully to make sure this line is doing exactly what I want. Okay, so because the error messages are often confusing, the important thing to note is don't write a lot of code without compiling. Because if you write a whole bunch of code and it doesn't compile, it's often not clear which of that new code is causing you problems. So the way that I generally write code is I write a little bit of code, I compile it, make sure everything is happy, write a bit more code, compile it, make sure everything is happy, sometimes run the compiled code to make sure that it's generating the correct output and things like that. Compiling is free. Do it as much as you can, because if you write a whole bunch of code and it doesn't compile, it's a lot harder to figure out which line is causing you the problem than just, oh, it must be in these last 2 lines that I wrote. I better look more carefully at these guys. Okay, so what we're going to do now is we're going to look at your first Hello World program. Hello World is often what you do when you're learning a new programming language. And so we're going to walk through the different parts of this line. So the first thing to note is that the first line has this include right here, include IOStream. What's going on there? So includes allows you to include, which is why it's called includes, a library in your code. And so this is very similar to import in Python. If you are using the recommended textbook, if you go to the first appendix there, it shows you all the different sorts of includes you can do from the standard template library. Now in this code, we're including IOStream, which is input output stream, which lets us do things like output strings to the terminal. Now what's this little octothorpe, this hash sign in front of it? This is denoting what's called a preprocessor statement. This is saying, hey, this actually isn't an instruction for the compiler. This is an instruction for kind of the preprocessor. It's the part that gets processed before the compilation takes place. Important thing to note, it doesn't have a semicolon at the end. You'll often be tempted to throw semicolons everywhere because C++ really likes them. But the preprocessor statements don't have semicolons. And what you put between the chevrons is the name of your library. Now note, we'll be talking about header files later on in the class. For right now, you don't have to worry about them. But note, there's no extension on this. It's just IOStream, not .h, not .hpp, just IOStream here. Okay. The other thing to note about our code is that it has comments. So there are actually 2 types of comments in C++. There's what's called a multi-line comment that has a slash, an asterisk, and then other characters, and it ends with an asterisk and another slash. Anything between this pattern of 2 characters and this closing pattern of 2 characters is part of the comment, including new lines, things like that. It's called a multi-line because you can include new line characters as well as any other character between these comments. The other type of comment, the single line comment, just has 2 slashes, and then everything up to the end of the line is part of the comment and is ignored. So these are often used for very short comments. Okay, the other part of the program is called main. What this is every program that you'll write in C++ has a main program. This is the part of the program that actually runs. This function will call any other functions in your code. This function is basically the point of entry into your program. So every program you ever write in C++ will have a main function that you'll be using. Okay, functions are composed of a couple different parts. The function name is right here. Guess what name this function has? It's main. Before the function name is the return type. This is the type that this function will return. The main function traditionally returns type int or integer. We could talk about that later about why it returns type int. Don't need to worry about it now. After the name of the function, you have the argument list. Just like in Python, the main function, the way that we're using it right now, doesn't have any arguments, so you just have open, close parentheses. Then you have an open curly bracket and a closed curly bracket, which denotes the beginning and end of the function. In between these open and closed brackets, you have the actual body of the function, which is here is doing the actual output of hello world. The curly brackets, just like most punctuation in C++, can have multiple meanings. What it means here is that it's denoting the block of a function, which is basically the part of a function that runs when you invoke a function. A curly brace can also denote a sequence of statements that you can put wherever you are allowed to have a single statement. We'll talk about statements a lot later. The other thing that we should make really clear early on is that indentation and basically any type of white space doesn't mean anything to the compiler. It's only meant to help you who's writing the code and whoever needs to read the code later. Indentation is a lot like comments. It makes your code more legible, but it doesn't actually change what your code does. So if you wanted to be evil, what you could do is you could remove as much white space as you could from your program. So for instance, I'm here removed all the indentation, all the new lines. This is actually just one line of code that wraps around because it got too long for the slide here. This program means the exact same thing as the previous program. When you run it, it'll compile just fine, it'll run just fine. However, hopefully all of you will admit it's much harder to read and even harder to understand when we removed white space, even if the white space isn't meaningful to the compiler. Okay, so what are other parts of this Hello World program? Well, now note the std : cout. Now this is saying that we're reaching into the std namespace. No, this isn't a reference to transmitted diseases. Std is short for standard, aka the standard template library. So it's saying in the standard template library, there is a function called cout, or specifically a stream called cout. So when do you use the std namespace? Well, most of the time when you're using the standard template library, you're going to need to prefix them with std. We'll talk a lot more about namespaces later. The standard template library uses the std namespace all over the place. Yes, it's an unfortunate acronym, but for right now, just when I show you how to use it in that way. Now, one thing to note is you might be going, is std a good name? And in C++, there's a lot of acronyms. There's a lot of shortened words. Why? Because if you have to type out a word a whole bunch of times, it's more convenient if it's shorter. If you have to read a word a whole bunch of times, if it's a shorter word, it's faster to read. So some languages, like C++, like to shorten words as much as they can. Other languages, like Java, tends to write words out in their full form. Unix, which we're teaching you the command line, and that's kind of the Unix environment. They do some pretty weird things with words, and you just have to learn it. The different languages, different environments have different conventions. C++ is kind of somewhere in the middle there. So what is that : thing there? It's called the scope resolution operator, which is basically saying that, hey, there's a name called cout. You need to look for that name in the namespace std, and the : the scope resolution operator basically says where to find cout. Find cout in the std, aka the standard namespace. Alright, so what is std : cout? This is what's called a stream, and a stream is a particular data structure that is able to move data from one place to another. So why did we say include IOStream at the beginning of the program? Because there's a bunch of different streams, notably 3 that we're going to spend a lot more time in this class on. Cout is short for console output. It's used to write data, to mostly strings, to the output for your console. What's cin for? It's short for console input. It's used to take data from the terminal and provide it to your program. There's another one that we use a little bit more rarely called CAIR, console air, and this is another output stream, but it's mostly used to communicate error messages instead of standard regular output. We'll talk about when to use cout versus CAIR much later on in the course. Okay. So what's the next weird thing in this program? There's these less than. This is what's called the insertion operator. It's used to mostly with streams to move data from one place to another. What's being moved by this insertion operator? Well, the hello world string, which is just coming up next. So how do you output from programs? Well, what you generally do is you use this insertion operator, this less than. And so what you have is you have a stream on the left, the insertion operator, and then the thing that you want to output. And it's a binary operator, meaning it returns the stream that's being used, which allows you to chain them, which is something that I'll show you guys later. Now, what is being outputted? Well, usually it's strings, which are denoted between those double quotes, or, for instance, a C++ variable. Now, one thing that I have to make very clear, especially those of you who are coming to this class from 231, meaning that you know Python, in Python, strings can be denoted in two ways. You can denote them with double quotes or single quotes. And they're really pretty much the same thing except which character you have to escape within. But in C++, it's very different. I want to make sure that this is clear. Once again, especially if you come from Python, this is very different in C++. In C++, strings use double quotes, only double quotes. Single quotes denote a character type, a char. This is something that's very different from a string. We'll teach you about chars later. But for right now, if you need a string, if you need a sequence of letters, use double quotes and only double quotes. Okay, what's going on at the end of the line? Statements end with semicolons. You're going to be using semicolons quite a bit. Now, once again, statements end with semicolons. Not every line ends with semicolons. So, once again, the difference between statements, lines, expressions, declarations, blocks, things like that, you'll learn this terminology as we go. For right now, I strongly recommend looking carefully at all of the code examples that we show you. Get used to where you find semicolons, get used to where you don't. Another smart way to go about this is if you find a good editor that's good at C++, it'll often warn you when you're missing a necessary semicolon. Alright, so talking about semicolons, the important thing to note here is that there should be a semicolon after the hello world, which is denoting the end of a statement, but you don't put a semicolon after the closing bracket because that's not ending a statement. Okay, the other thing to note is that as important as it is to write code for the compiler, it's also important to write code for a human reader. We talked about how removing white space to just like make it the shortest program you can is not a good idea because it makes the program much less readable. Same thing applies to writing well-styled code. We'll be talking about what is good style, what's bad style as we go. But for right now, the important thing to note is you want to write code that, yes, compiles, yes, runs correctly, but also makes sense to people who can read C++. So what we're going to do is we're going to use one of the more popular style guides, notably Google's style guide. Google writes a whole lot of C++ code, and so they developed a style guide for making sure that all of their programmers were able to write code that other programmers would be able to read well. And what we're going to do is we're going to use their style guide. Now, their style guide is quite long, but there are sections of it that we will be pulling from when we need to. So, for instance, we'll be looking at their sections on how to name things well and things like that. Okay, so let's talk a little bit about naming things, because this is one of the most important decisions you make when you're writing a C++ program, or really any program for that matter. Now, the rules we need to talk about, these are things that the compiler will enforce. So you can't break these or else your code won't compile. So what are you allowed to use in a variable name? Well, you can use digits, 0 through 9. You can use letters, A through Z, uppercase and lowercase, and underscores. Those are the only characters that are allowed in a name. You're not allowed to have any emoji in your C++ variable names. Now, you are allowed to do that in Python, but probably a bad idea generally. What are the other rules? Your names cannot start with a digit. They have to start with either a letter or an underscore. All right, that makes sense. Case matters. Cat, all lowercase, is a different variable than cat, all uppercase, which is also a different variable than capital C, lowercase a, capital T. So case, whether it's uppercase or lowercase, matters here. The other thing that matters is the namespace for the name, meaning if you make a name that's in the STD namespace, that won't clash with a name that's just in the regular namespace for the program. We'll talk about namespaces a lot later, but this is mostly here for if you're looking back. Now, the other thing to note is style. So these aren't things that the compiler will enforce, but these are things that I will enforce. So generally, you want to choose good, clear names, and we're going to use the Google Plus, or not the Google Plus, we're going to be using the Google Style Guide, which encourages variables to be entirely lowercase with underscores between the words. So these are the same naming style that you've learned from if you've taken 231 and learned Python. The nice thing about having these is it makes it a lot easier to read. You're not using unnecessary acronyms. Strongly recommend doing this. The other thing you want to do is you generally want to choose meaningful names, names that make sense in their context. Don't be using jargon and things like that unless you have to. The other style that, once again, doesn't affect if your program runs correctly or not, but it helps with readers, is comments. Often you want to put a comment at the top of your C++ file that has, for instance, your name, the date, what this file is supposed to be doing. You generally don't need a comment like for variable names. If you choose good variable names, they'll be self-explanatory. They'll explain what they are. Functions generally should have comments. They should explain what arguments they take. They should explain what they return. They should explain how they go about what they're doing. So another place where you might want to write comments is wherever you have complicated, difficult to understand code. So the idea is if it was hard to write code, it would also likely be hard to read that code. Provide comments that explain what your code is doing, why your code is doing it that way, for your own sake, because if you ever need to adjust that code or need to understand what that code does later, for the people grading your code, like your boss or your partner, or perhaps the most important critique is your future self. If you ever have to go back and look at your code months later, having good comments, writing good variable names makes your life so much easier. Alright, so now looking back at this Hello World program, hopefully everything should start to make sense now. We're including the IOStream library, which is part of the STL. We have a multi-line comment. We then have our main function that returns an integer, doesn't take any arguments, with a block denoted by those curly brackets. And in that block, we have the cout stream that's part of the STD namespace. And we're inserting into that stream the string hello world.